Scene script. Have you ever wondered, if you could travel back in time, could you prevent your own birth? Time travel. The phrase alone conjures up images of fantastical journeys, of spiraling wormholes and flashing lights, of alternate histories and futures not yet written. It's a concept that has fascinated us for centuries, inspiring countless tales and theories. But is it more than just science fiction? Could it one day become science fact? Let's venture down this rabbit hole together, shall we? Picture yourself stepping into a time machine, dialing back the years, and setting a course for the past. You arrive, let's say, a few decades before your birth. What happens next? Could you, in this hypothetical scenario, prevent your birth from ever occurring? It's a mind-bending proposition, isn't it? It's as if we're trying to solve a puzzle with pieces that don't quite fit. If you prevent your own birth, then you wouldn't exist. But if you don't exist, how could you have traveled back in time to prevent your birth in the first place? This is what we call a paradox, a situation that defies intuition and seemingly contradicts reality. Paradoxes are the bread and butter of time travel theories, and they're what make the concept so endlessly fascinating and confounding. When we think about time travel, we're not just pondering the possibility of hopping in a DeLorean and gunning it to 88 miles per hour. We're grappling with the very nature of reality itself. We're asking questions about causality, about the nature of time and space, about the linearity or non-linearity of our existence. So let's circle back to our original question. Could you prevent your own birth? The answer is, well, it's complicated. It's tangled up in theories of relativity, in quantum mechanics, in philosophical debates about determinism and free will. Imagine the confusion if you went back in time and stopped your own birth. Where would that leave you? Enter the world of time travel paradoxes where things get a bit complicated. So what is a paradox? In the simplest terms, a paradox is a statement or event that contradicts itself, yet somehow could be true. It's like saying this statement is false. If the statement is true, then it must be false. But if it's false, it must be true. Confusing, right? Now imagine adding time travel into the mix. Time travel, as we understand it, introduces the concept of causality, a fundamental principle that asserts cause must precede effect. In other words, an action in the present influences events in the future. But can it affect the past? That's where things get tricky. Consider this. You invent a time machine and travel back to an era before you were born. Now, in this past timeline, any action you undertake could potentially alter the course of history, leading to a different future. This is where the concept of a time travel paradox comes into play. One of the most famous time travel paradoxes is the grandfather paradox. Imagine going back in time and accidentally preventing your grandparents from meeting. This action would prevent your birth, thus making your trip to the past impossible. But if you never went back in time, your grandparents would meet, and you would be born, allowing you to take the trip that prevents their meeting. It's a loop that can't be resolved, a true paradox. Similarly, there's the Bootstrap Paradox, which involves an item or information that exists without a discernible point of creation, because it's continuously looped within time. But we'll dive deeper into these paradoxes in the upcoming scenes. The crux of the matter is, time travel paradoxes pose serious questions about the nature of reality and our understanding of time itself. So, if you alter the past, you might end up with a future where you never existed to change the past in the first place. Perplexing, isn't it? Consider the grandfather paradox, the classic example that stumps even the most brilliant minds. This paradox plunges us into the depths of the time travel debate. It's an enigma that has puzzled scientists, philosophers, and your average Joe alike for years. Now imagine this, you've somehow managed to get your hands on a time machine. You decide to go on a little adventure, so you travel back in time, say 50 years or so. There you encounter your young grandfather, blissfully unaware of what the future holds. In a moment of madness, or maybe just curiosity, you decide to alter the course of history. You kill your grandfather before he has a chance to meet your grandmother and have your parent. This is where the paradox comes into play. If your grandfather dies before he has children, your parent would never be born. And if your parent isn't born, then neither are you. But if you were never born, then how could you have traveled back in time to kill your grandfather in the first place? It's a chain of events that contradicts itself. The implications of this paradox are profound. It raises questions about the nature of time and our place within it. Is time linear, a straight line from past to future? Or is it more of a web, where every decision we make creates a new thread, a new possibility? Some suggest that the grandfather paradox proves time travel to be impossible, as it would violate the principle of causality, the idea that a cause must always precede its effect. Others propose the existence of parallel universes or alternate timelines to resolve the paradox. But regardless of the theories, the grandfather paradox remains a conundrum that challenges our understanding of time and reality. It forces us to question our assumptions and to think outside the box. As we delve deeper into the mysteries of time travel, paradoxes like these remind us of the complexities and wonders of the universe we inhabit. If you no longer exist, how could you have killed your grandfather? It's a mind-bending loop, isn't it? Next on our list is the Bootstrap Paradox, a paradox that truly challenges our perception of cause and effect. Imagine a scenario where an item or piece of information is sent back in time. This item or information then becomes trapped within an infinite cause-effect loop. This is the Bootstrap Paradox, a concept that truly tests our understanding of how things happen and why. Picture this. A time traveler finds a rare manuscript of a famous book in the future. Intrigued by its mystery, he decides to take it with him on his journey back to the past. Once there, he meets the young author of the book and gives him the manuscript. The author then publishes this manuscript as his own work. Now, here's the catch. The book the time traveler found in the future is the very same book that the author publishes in the past. So, who actually wrote the book? The Bootstrap Paradox forces us to question our understanding of cause and effect because it presents a situation where an effect precedes its cause. In our manuscript scenario, the effect is the creation of the book, but it appears before its supposed cause, which is the author writing it. This paradox opens up a Pandora's box of questions. If the book didn't originate from the author, then where did it come from? Who wrote the first draft? It seems to have no beginning, no point of creation. It just exists. The Bootstrap Paradox doesn't just apply to physical objects, it can also relate to information. Suppose a scientist receives a detailed theory about time travel from her future self. She publishes the theory, it becomes widely accepted, and she eventually sends it back to her past self. Again, we're left wondering, who originally came up with the theory? The Bootstrap Paradox pushes the boundaries of our comprehension. It presents a loop with no discernible start or end, challenging our conventional understanding of time and causality. It's like the chicken and the egg dilemma. Which came first, the information or the source? Time travel paradoxes are fascinating, aren't they? They challenge our understanding of reality and our place in it. We've journeyed through the winding roads of time travel paradoxes, traversing the landscapes of the mind-boggling and the unimaginable. Let's take a moment to retrace our steps, shall we? We began by pondering the very concept of time travel. We asked ourselves, what would it mean to journey through time? How would our actions in the past or future affect the present? The answers, as we've discovered, are far from simple. We then delved into the depths of time travel paradoxes, those enigmatic phenomena that defy our conventional understanding of cause and effect. We learned that these paradoxes present situations where our actions in the past can drastically alter the present, sometimes in ways that make our original actions impossible. Remember the grandfather paradox? That's the one where you travel back in time and accidentally prevent your own existence. A real head-scratcher, isn't it? It's a paradox that challenges the very fabric of our logical thinking, where the cause and its effect seem to annihilate each other. And let's not forget the Bootstrap Paradox, the time travel scenario where an object or piece of information sent back in time becomes trapped within an infinite cause-effect loop. It's like a chicken and egg scenario where it's impossible to tell which came first. These paradoxes, while puzzling, give us a glimpse into the complex nature of time and the universe. They challenge our conventional understanding and compel us to think beyond the linear progression of events. They remind us that the universe is far more intricate and mysterious than we can ever fathom. So next time you wish to hop in a time machine, remember, you might just end up in a paradox.